Welcome to a video by Abron report. This is a Hall Pro. This is a Hall effect electromagnet which is going to USA. This one is a Hall Pro. It's not a part of the instrument. This one only is a electromagnet. We have showing you the video. This power supply is having a variable current and it can go up to 0 to 0 to 5 amperes. But the voltage is 0 to 60 volt DC. This is going. We have to connect the positive to positive. Internally it is connected. We have got another model where these two magnets are connected outside, so you have to connect them in parallel. This is a probe which is there. It's a crystal probe, N-type probe, and there is one which is again a P-type probe. We have got the two probes. They are asking for two probes which are going. This stand is not a part of the instrument. So first of all we put a check up the initially. When it comes to you, these are the two sections which will be separated, and you have to connect all these, both the sides, and then connect it to the just rotate it, and this will fit to the instrument, and then you can rotate it. See, inside there is a gap. The gap you can adjust. See, this inside you can adjust the gap by rotating this section. I have just adjusted almost 10 mm. Now initially for the first of all you have to, for setting you have to set it on 0. Here it is showing some value. This probe is showing some value. This should be off. So there is no electromagnet, there is no magnetic power. Here we are just putting this magnet as a 0. Initially setting is a 0. Like this, you have to just see this go there. I am not putting any, this probe goes to negative, and you have to again put it to almost positive. Now this is almost positive. This is a basic setting, starting of the probe setting using. But when we put this electromagnet, suppose I am putting this electromagnet and checking, I switch on, this power is almost 0. So when I increase this power, increase this, say I increase it to 1.9, so there is always a value here. You can see it is a negative. That is only because it is on the other side. So I can just put this way and see the value has come. The value is more than it can be seen on this. There is one 2K, 20K and 2 kilowatt. I can make it on 20 kilowatt. If the value is suppose coming to negative, that means, see, this is negative. That means the probe here is on the other side. You have to connect it to the other. There is here, you can do this and see this value, and here also you can see this value. So there is a this is a brass, so the value can be adjusted and seen here. You can adjust it and seen. This is the value. Now it is showing 1.8, 1.91. This is the probe, and initial you need this instrument also. Now for connecting the probe, it has two. We have got the initially there are two parallel wires are connected. Here we have adjustments. This crystal is there. It is in this also. There are 4 wires which are, 2 can act as a power which will be connected to the unit. These are, we have provided these different kind of pins. 2 are thicker, 2 are thinner. So you can put this inside the thinner one or the thicker one. But if you do not have any, both are same, it calculates the value of input millivolts and what is the output current. One is giving the current and one is just reading. So I can adjust it and see this. There is a adjustment. This one is a, and now there is one probe which is N-type and this is one P-type. I have put the N-type inside and the value will be, now I can change the current. See, this current is changing, and there is a how much current is going in and how much current is coming out. On the same value I can change this power to higher and read this, how much is the gauge and then what is the reading. This will change. Similarly I can increase it to any amount, and then this will be showing you the different readings. So you have to plot how much current is coming and what is the, how much effect is coming. This is the study of the effect. What is the magnetic effect on the crystal? So similarly there are two probes. One is a P-type, this one is a P-type probe, this one is another one is an N-type probe. They both are going to USA. So they are for different, and they already have these power supply. Only we are sending the electromagnet. So very easy to use. So but we recommend you to use our full system, but anyway you can get a different parts. But you need a Hall gauge meter or flux meter to measure the how much magnet is being produced. You can always keep it on 0 or off, then how much magnet is being produced and what is the effect of the crystal. Please visit the website and share the videos, like the videos. Here you can check up. This is our email, abron01@gmail.com, and WhatsApp number is 999 2222 in India, and another is 94160 20018. Website is abronexports.com. We supply to different countries. And this very important thing, this is up to the 60 volt. This is up to the working is up to the 60 volts, and up to maximum is 5 amperes. This is the capacity, so that it generates, and the gap can be adjusted. This inside is 12. If you increase, you can reduce the gap. You can reduce the gap. You can reduce the gap here. You can see this gap is coming down. You can reduce it. The power will increase. You can increase the gap by rotating these. I mean, just increasing and decreasing the gap. So that will change the effect. But generally, it is done. The experiment is done on 10 to 12 mm of this gap, and the maximum you should have the digital power supply with the voltage and the current. This is a very important thing. Please be careful. Take care of the instruments and subscribe to the channel. Like the channel. There is another instrument similar by our instrument. See that video also. Thank you very much.